In this lecture, we will develop an overview of a chilled water system. Shown on this slide is the schematic diagram of a typical small to medium sized chilled water system. Notice that the chillers and chilled water pumps are located on the terrace floor. Not shown in this schematic is the condenser water system, which presumably, along with the cooling towers, will be entirely located on the terrace. The chillers are configured with N+1 redundancy. That is, while N chillers are active, one chiller is kept in cold standby mode. Similarly, the pumps are also configured with N+1 redundancy. The pumps pump chilled water to the 4 floors of the building, namely ground, first, second and third floors. On each floor, one or more AHUs transfer heat from air to the chilled water. The warmer chilled water is returned to the chillers on the terrace, while the conditioned air is ducted into the rooms on the same floor. A typical chiller configuration is shown on this slide. There are 3 chillers here. While 2 of the chillers are active, one of them is kept in standby mode. Typical chiller connection details are shown on this slide. Notice the motorized butterfly valve to enable blocking of flow from non-working chiller. Notice the 2 butterfly valves at the 2 ends of the chilled water chiller piping, which enable the chiller accessories in the line connecting to the chiller to be isolated and serviced. A balancing valve is placed on the supply side to ensure that the right amount of chilled water flows out of the chiller. Notice the pressure gauges and thermometers installed in the supply and return piping of the chiller. Notice also the rubber bellows at the connection ends of the chiller. These eliminate transmission of vibration from the chiller to the piping. Turning our attention to the pumps, each pump has 2 butterfly valves at the end of the piping circuit to allow the pump and accessories to be isolated and serviced. A non-return valve is placed on the discharge pipe of the pump in order to avoid backflow of water from the pipe of the non-working, that is standby pump. A Y strainer is installed at the pump inlet in order to keep dust particles out. Pressure gauges are installed at the supply and return of the pump. Vibration isolation rubber bellows avoid transmission of vibration from the pump to the pipeline. We now turn our attention to an AHU. As shown on this slide, each AHU pipeline will have butterfly valves at the 2 ends of the pipeline. These are meant for isolating the AHU and accessories in the pipeline to be isolated whenever they are to be serviced. Pressure gauges and thermometers are installed at the supply and return of the cooling coil. A Y strainer is installed at the inlet of the cooling coil to ensure that dust particles do not enter the coil. A three-way mixing valve ensures that only the right quantity of chilled water enters the coil, with the rest being bypassed across the coil. The three-way mixing valve piping diagram is shown on this slide. The valve is usually motorized. Its actuator position is decided by the temperature of the return air at the AHU room. Full open when the air is warmer than the required temperature, and more bypass of water as the temperature gets closer to the set point. In the next lecture, we develop an overview of the condenser water system. Thanks for watching.